And the big question is, how do different species interact with each other? And so we're going to see positive interactions, and we're going to see negative interactions. We're going to see interactions that support and make their survival easier, and we're going to see interactions that actually make their survival more difficult. And so keep in mind, if you remember from our evolution, we can actually see that because of these relationships, sometimes we will have co-evolutionary relationships. So if organisms have a strong and steady enough relationship, sometimes that will lead to impacts on how well they survive and which organisms survive. When we look at what a community is, we're still only looking at the living organisms. And we're looking at their impact on each other. And so I really liked this graph because it actually showed, basically consider this an experiment, as if we had an empty ecosystem and we put in one organism. And when we put in that organism, it experienced exponential growth because there were no limits to it. But then when we put the second organism in, then these organisms started to compete. Less of the initial organisms survived. This organism was able to find its own niche. So I want to throw the word niche out at you. A niche is really the set of circumstances. So the set of the environmental conditions or circumstances a species or an organism uses. So, keeping in mind that an organism and a species are not really alone out there, that they interact, even though it finds its niche, that may not mean it gets to keep that niche. And that's why invasive species are such a problem, because we have a mature and dynamic ecosystem, and once we add something, that can change the entire way that the populations interact. So the big idea about communities is that in a mature community, we're going to see fluctuations still. But it's going to be more dynamic. It is going to be dynamic, but it's going to follow a cyclical pattern. Versus if we introduce new species, then we're going to start to see pretty dramatic shifts in what's existing there. So that's kind of the key. In a community, you are going to see what's called partitioning. Partition means to separate, and we're really talking about separating resources. So I like that this is over time. The interesting thing would have been, is this over like days and hours, or is this over generations? Keep in mind that for most organisms, you're talking over generations. Some organisms can adapt behaviorally, right? So that's why I hate the use of the word adapt in normal conditions, because your parents make you move schools and they're like, oh, you'll adapt, you'll get used to it. Only some organisms can experience conditioning. Only some organisms can experience the type of conditioning where you start to ignore things. And so really what we're usually talking about more is over generations. Limited resources can lead to competition. And so in a mature ecosystem, we are going to find that in order for that species to survive, it has to kind of partition and find the best place for its survival. If we introduce new species, that's where we start to see different trends. There's a term called competitive exclusion. What we did not see in this graph is we did not see the purple species completely go extinct. We saw that somehow there was some sort of dynamic going on there. Each organism, each species was able to survive. In competitive exclusion, you are excluded because of competition. So one organism or species is not able to compete and may go extinct. And so I really like this graph. It shows you what happens if this organism is grown on its own, what happens if this organism is grown on its own, and then what happens if we grow the two together. So when we grow the two together, we can see that the first organism is more successful than the second organism, and that the second organism is basically going to be excluded, and that's competitive exclusion. Because of competitive exclusion, we do see the pressure to compete, and what we mean by pressure is selection force. Now keep in mind, we might be competing for food, we might be competing for space. Between species, there's not competition for mates. The definition of a species is that you can only mate together. So when we're talking about this type of competition, we're usually talking about resources that are not innate. And so the main idea of a community is we've got multiple species competing for limited resources, and the organism that best survives, that best competes, is going to be the one that is able to kind of take over and have the lion's share. However, some species will kind of coexist. So it's this idea of, in an ecosystem, in a community, are some better than the other, or are they able to kind of share resources? Species may interact in a permanent relationship. You probably already know mutualism. Please make sure that you have an example of each of these that you could discuss. So I just wanted to kind of share a couple with you. A few easy facts to try to remember. Most people know what mutual means, like you both feel that way. It was a mutual breakup, we both wanted to break up, we were both equally, whatever. Or our love is mutual, right? It's equal on both sides. The main one that I would encourage you to talk about is pollinators. But there are actually a lot of other examples. So for example, with leafcutter ants and fungus. And I'm going to post a video of this for you today, for you to watch tonight. The leafcutter ants actually cut leaves not to eat themselves, but to feed to a fungus. And so the fungus gets a place to live and gets to eat, and the leafcutter ants will eat the fungus, but only a certain amount. They would never eat the fungus down to nothing. They maintain that fungus at a very stable environment. Commensalism, I want you to notice the O there, plus O, means one organism benefits, the other does not. Bromeliads are an example of this. You may not know them really well, so the best example that I like to talk about is barnacles and whales. Barnacles are animals that live inside of a shell. They're filter feeders, which means they need a constant source of water rushing by them. This is why you'll find barnacles growing on the sides of piers where the waves are breaking. This is why you'll find barnacles growing on the bottoms of boats because the boats are moving. But barnacles also grow on whales, and or other organisms that are going to be moving a lot. And so it doesn't hurt the whale, it doesn't help the whale. It's a commensalistic relationship. Most people know parasitism really well. Fleas, ticks, mosquitoes, tapeworms. If you can see, probably not in your picture, but maybe in this picture, this is actually a test that was able to actually show the tapeworm. So don't drink unsanitized water, because there could be tapeworm larvae in them. And then it grows to reach the length of your entire intestine. It attaches to your small intestine, sucks your nutrients, and you wither away. And once it gets diagnosed, you have to take a pill to kill it, but then you still have to excrete it. Have fun.
You have to poop it out?
Yep.
The whole thing?
Yep. Maybe not all in one piece.
Pull it out.
If there is one term I really want you to know, it is keystone species. You may have read it there in your learning objectives. A keystone, if you think of a natural arch that was built with stone, a keystone is the one that is most important. If you pull that stone out, the whole arch collapses. So you can make an arch without any like cement or things gluing them together if you stack them correctly. You usually need supports to help you build it until you put the keystone in, and then the pressure from both sides actually supports it. Here they're using the keystone to say these species have a much bigger impact on the ecosystem. So for example, beavers. Beavers are going to be able to build dams.
Good afternoon, Butler
Those
students and
dams
staff. I
have
hope
a
you had a
dramatic
great day.
effect
It's
on
about 72
many
degrees
species,
outside and
not just
partly
themselves.
sunny, so you should be able to have all your afternoon outdoor activities and have a great time. First, I need the following students to report to the main office for messages at the end of the day. Ann Lee, Malachi Haynes, Nywan Williams, Ruth Flores, Brandon Long, Cole Estes, Cody Klutz, Caleb Van Noy, and Shimon Moore. This is a short reminder to all bus riders. Make sure the bus you ride is the one you are assigned. CMS policy only allows students to ride the bus they are assigned due to liability concerns. If you are found on a bus you are not authorized to ride, you risk losing bus privileges along with other school consequences. Notes from parents are not allowed. Thanks for your cooperation. See Mr. Stoughton in the morning if you have any questions. And he'll be out on the bus lot this afternoon as well. Minority Achievement will meet Thursday after school in room 415. Please be on time. Refreshments will be served and door prizes will be given. The Butler High School Choir and Jazz Band will present an evening of jazz and songs from Broadway musicals on Thursday and Friday, April 25th and 26th in the auditorium at 7 p.m. The show choir will feature songs and solos from Godspell, Joseph and the Amazing Technicolor Dreamcoat, Little Shop of Horrors, and In the Heights. I've got to find out what that one is. Admission is $5. Herb Jones will be on campus to deliver caps and gowns during lunch this Friday, April 26th. Seniors, you're getting close to the end. Now I have some wonderful students up here to give for a couple of more announcements.
Hey Bulldogs, this is Jessica from SCA. Don't forget, tomorrow morning at 6:40 in room 957, we're having our next meeting. Also, mark your calendars for Monday, April 29th at 3 o'clock. We're having our spring service in the SCA service in the auditorium. There will be awesome worship and a fantastic leader. See you guys there. Hey guys, it's Lucy from Student Council, and Butler is having a color run on May 18th starting at 9 a.m. To register, go to colormyrun.com. We are starting in the stadium and ending with a splash bash party in the bus parking lot. It's going to be $35 and tons of fun. There's also now a group discount, which is $210 for 7 people, and registration ends on May 16th. You'll be registered by class, and whoever class has the highest attendance gets a $500 prize.
So first we just looked at
Thanks
how
all. Have a nice
population
day.
grows, J-curve, S-curve, patterns of those graphs. Now we look at how having multiple populations can affect that. This kind of fits under ecosystems because we're starting to look at things like rock. But primary and secondary succession, primary succession is when there's like a volcano and you have an entirely new place for things to grow. Secondary succession is like a fire or a flood. So there was something there and then something destroyed most of the life that is there. When there's this idea of an entirely new place to live, you usually have to have some species that have unique adaptations that allow it to live in that very harsh environment. So not everything could live in that harsh environment. And lichen is a mutualistic relationship between a fungi and an algae. And then lots will be able to grow during a middle stage, and then eventually mature organisms will actually inhibit any new growth. And so shade from large trees gives far red light. Far red light, we know, inhibits seed germination. Secondary succession is basically where, this is like when you see construction companies that do clear cutting. and they'll cut down and they'll churn up the soil. It's not an entirely new ecosystem, but other organisms get a new chance to come in and kind of be the pioneer species there. So just being able to kind of talk about how does competition affect this. The last part, and I really didn't see this, but I just want to mention it, is aquatic changes. The amount of light that is able to penetrate the water is really important for how well your producers will be able to grow there. So if we start to get a lot of sediment in the aquatic environment, then it starts to become really hard for your producers to live, and then we start to have other effects. So I'll film our next video tonight. Cheers, hardcore. You guys are being real hardcore, getting through this real quickly. And I will see you tomorrow.